dipole in the sense, if you take two charges, so let's say two equal and opposite charges separated by a small distance constitute an electric dipole. So if we have a two charge, so minus q and plus q with a distance of r, it will produce a dipole. So this is a distance from midpoint of the dipole to the one end is a. This is a. Totally we have a 2a distance. So the dipole. And also we know what is dipole moment. So dipole moment will be defined as equal to 2a. So this is called the dipole moment of the charge. So now let us calculate the electric field due to the dipole at a point on an axial. So this is a simple diagram to understand. The dipole is placed on an axial line. Here there is a point C. Now we are going to calculate the electric field at this point due to the positive charge and also due to the negative charge. Understand? So this is the dipole from here to here. So we get the two charges, opposite charges, which are equal in magnitude. Minus charge is placed at a point A, positive charge is placed at a point B, and this will create a dipole. This is the dipole moment which acts along BC. So now let us calculate the electric field. The electric field due to the positive charge is given as E plus E vector, that is equal to 1 by 4 pi epsilon r q by r minus a, the whole square. We have the general formula for the electric field is 1 by 4 by epsilon r q by r. So this is the general formula. So r says the distance between the charges. So here r is replaced as r minus a. R is replaced as r minus a. Why? Because we are taking only the distance between the positive charge and the point C. So we know the distance, that is the midpoint of the dipole. From the midpoint of the dipole to the point C is r. So if we want to know the distance from point C to positive charge, we have to subtract this distance from r. Understand? So that we write r minus a as a distance of the distance between the positive charge and the point C. So we can also denote that as like this, r minus. Understand? So this is the electric field. This is actually along the charge lines, and the field direction is along BC in this direction. That is why we write along BC. Now let us take the electric dipole moment vector. Electric dipole moment. So this equation can be replaced as 1 by 4 pi epsilon r q by r minus a whole square p vector. Now p vector says the electric dipole moment vector. So this is the direction of the charge, direction of the electric field. This shows the direction of the electric field. So calculate the electric field due to the negative charge. So now we calculated the electric field. This is the electric field due at a point C due to the positive charge. Understand? Due to this positive charge, what is the electric field? This is the okay. Now let us calculate the electric field due to the negative charge, which is placed at the point A. So let's write. For the electric field at the point C due to the negative charge. So this minus sign we will place it over here. So this gives a negative value, and now let us see this distance R plus A. How? So we are taking the distance from C to the point minus charge. Understand? So we know the distance from C to O, it is R. So another we have to come up to this side, so that from O to minus Q it is R. The distance is A. So R plus A. Now it will be the total distance from C to minus charge. It is R plus A. Understand? So that is why we write like this, R plus A into P cap. So now let's calculate the total electric field at a point C. So now we have to add two electric field so that we can get the total charge, total field. So E total we will take the common factor outside. We will get this Q we will take outside. Inside the bracket we will have only 1 by R minus A whole square minus 1 by R plus A whole square, and here we have. Understood? Now let's do the cross multiplication. We will have 1 by 4 pi epsilon naught, and here it is R plus A whole square minus R minus A whole square divided by, so if you have R minus A whole square or R plus A whole square, we will have the formula, right? That is R square minus A square whole square. So R square minus A square whole square. So now this we can over here. Let's do the calculation. P total, that is 1 by 4 by epsilon naught. Now we know the formula A plus B the whole square. We have to apply this formula A plus B the whole square in this equation. So let's say R plus
square minus
Here is r square minus c square. R square minus c square. Let's keep this as we will simplify at the end. So now let us further simplification. 1 by 4 pi epsilon naught r square plus a square plus 2ra. So let's multiply this minus sign inside the bracket. Minus r square minus a square plus 2ra, right? So now this equation r square minus a square whole square. So in this topic, the distance of r is very greater than a, isn't it? So the dipole distance is very small. So for that now we can neglect the dipole distance by keeping only the distance of the point C and the point C from the dipole. So r is very greater than a. So now let's neglect, since the r is greater than a, we can neglect a square. So we can write as r square whole square. 1 by 4 pi epsilon naught. So this cube, let's write cube here. Okay. Now we can cancel the equations. Let's see, r square we can cancel. A square will get cancelled. We have 2ra, another 2ra. Totally
4ra.
4ra. So divided by r power 4. Right?
Yes, sir.
And we can. So now this r power 4, this r will get cancelled. Now let's see, 1 by 4 pi epsilon naught. 4. Can we split this 4 as 2 into 2? Right? 2 into 2. A.
Sir,
Divided by r power 3.
sir, q will be missing, sir. Q will be.
So now we know this dipole moment, isn't it? Dipole moment. Dipole moment, what is the dipole moment? P equal to 2qa. So we can replace instead of 2qa, see 2qa, we can replace as a big, right?
Yes, sir.
So let's write
D total
1 by
4 pi
4 pi
epsilon
epsilon naught
2
2p
vector.
by r cube, isn't it? So this is the total electric field. Total electric field at a point C. At a point C, due to the positive charge and the negative charge. Understand? So here, this arrow mark, the magnitude of the length of the vector is larger than the this negative, the electric field due to the positive charge, isn't it? Here we can understand the electric field strength is very stronger due to the positive charge, because the positive charge is placed near the point C than negative charge. So due to the positive charge, the point C is very closer to the point C. That is why the field created by the positive charge is very strong. That is why we get larger the length of the vector, as compared to the negative charge. So this is the total electric field produced by the two charges at the point C. It is very important topic. So study.